Have you ever looked up at the stars and wondered why everything seems so perfect? Imagine trying to bake a cake, but instead of having some wiggle room with your measurements, you had to measure each ingredient down to the individual molecule. Not just roughly, but exactly the right number of molecules. That's the kind of precision we're talking about when we discuss the universe's fundamental constants. The fact that you're here watching this video is like winning not just one lottery, but millions of lotteries simultaneously. Think about this. If you tried to write out the odds against your existence on paper, you'd need more paper than exists in the entire world. And yet here you are, a conscious being in a universe that seems tailor-made for your existence. It's like walking into a house and finding that every single measurement, from the height of the doorways to the temperature of the rooms, is exactly perfect for you. Not just close, but perfect to a degree that's hard to comprehend. Science teaches us something absolutely mind-blowing. The laws of physics are ridiculously, almost unbelievably fine-tuned for life. And when I say perfectly fine-tuned, I mean perfect in a way that defies imagination. Let me give you an analogy. Imagine trying to hit a specific atom on a target on the other side of the observable universe with a golf ball from Earth. That's still nowhere near the level of precision we're talking about with these universal constants. Let's dive into something fundamental, the electromagnetic force. This isn't just some abstract concept from your physics textbook. Think about boiling water for tea. Water boils at 100 degrees Celsius at sea level. Now imagine if that temperature changed even slightly. If water boiled at 90 degrees or 110 degrees, your tea might seem unaffected, but the entire chemistry of life would be dramatically different. That's similar to how the electromagnetic force works in our universe. This force is perfectly adjusted to allow stars to fuse protons and neutrons, creating carbon, the essential building block of life. But that's just the beginning. Let's talk about the strong nuclear force, which is even more precisely tuned. Imagine you're making a sandwich. The bread holds together because of the chemical bonds between molecules. The strong nuclear force is like the glue that holds the ingredients of atoms together. If this force were just slightly stronger, we're talking about a change smaller than 1/1,000,000,000%, it would be like having super glue instead of regular glue. Everything would stick together so strongly that only hydrogen could exist. Make it slightly weaker, and it would be like trying to make a sandwich with no glue at all. Everything would fall apart. Speaking of precision, imagine you're building a house of cards. Not just any house of cards, but one that's the size of a skyscraper. Each card has to be placed with absolute precision. If any card is even slightly out of place, the entire structure collapses. Our universe is like that house of cards, but infinitely more precise and complex. Then there's the weak nuclear force, which controls certain types of radioactive decay. If this force were slightly different, stars wouldn't be able to produce the heavy elements necessary for life. And we haven't even talked about the cosmological constant yet, which determines the expansion rate of the universe. Its value is so precisely tuned that physicist Leonard Susskind compared it to aiming at a target 1 centimeter wide from a distance of 15 billion light years. Now, most physicists have a fascinating way of explaining this seemingly impossible fine-tuning. They call it the anthropic principle, and it's one of the most profound ideas in modern science. Think about fish living in the ocean. They might think it's remarkable how perfectly water suits their needs, the right density, the right oxygen content, the right salinity. But of course, they wouldn't exist in an environment that didn't suit them. Fish don't exist in environments where they can't survive. They only exist where conditions are right for them. Here's another way to understand it. Imagine you wake up in a hotel room. Everything in the room is perfectly sized for you. The bed, the chairs, the height of the sink. You might think, wow, what are the odds that this room would be perfectly designed for someone my size? But then you realize you weren't randomly placed in this room. You chose it. Or someone chose it for you precisely because it was suitable for you. The universe works the same way. We're not necessarily here because the universe was designed for us. We're here because this is the kind of universe that allows us to exist. Out of all the possible universes that might exist, we can only find ourselves in one that has the right properties for life. But here's where things get even more mind-bending. Enter John Wheeler, one of the greatest physicists of the 20th century and a collaborator of Einstein. He proposed something so radical that it still divides the physics community today. The universe only exists because we observe it. When we talk about quantum physics and observation, think about social media. Have you noticed how people act differently when they know they're being watched or recorded? Quantum particles do something similar, but even more bizarre. It's like having a friend who acts completely different when you're looking at them versus when you're not, except in the quantum world, this isn't just behavior, it's fundamental reality. In quantum physics, we've discovered something truly bizarre. Particles behave differently when they're being watched. This isn't science fiction or philosophical speculation. It's been proven in laboratories around the world time and time again. Consider consciousness and its role in reality. It's like being in a dark room with a flashlight. The room exists whether you shine the flashlight or not, but what you observe only becomes real to you when you illuminate it. Our consciousness might work the same way with reality, not creating it from nothing, but converting possibilities into actualities through observation. Think about Wheeler's participatory universe like this. Imagine you're watching a choose-your-own-adventure movie, but one where your choices don't just affect what happens next, they affect what has already happened in the movie too. Every time you make a choice, the entire story reorganizes itself to make sense with your decision, even the parts you've already watched. That's similar to how our observations might affect not just the present state of the universe, but its past as well. When we talk about quantum entanglement, imagine you have two coins that are magically linked. No matter how far apart you separate these coins, when you flip one, the other instantly shows the opposite result. Not after a delay, not after any communication between them, instantly. Now imagine that instead of coins, this applies to fundamental particles that make up everything in the universe. This brings us to perhaps the most profound question of all. What if consciousness isn't just observing reality, but actually creating it? Think about reality as a giant coloring book. But this is no ordinary coloring book. Until you actually color a page, that page exists in all possible colors simultaneously. The act of coloring, observing, is what makes the colors definite. Our consciousness might be doing something similar with reality, transforming an infinity of possibilities into the definite reality we experience. Despite all our scientific advances, we still don't really know what consciousness is. We can map the brain, track neural activity, understand the chemistry of thought, but none of that explains why you have subjective experiences, feelings, awareness. None of it explains why there's something it feels like to be you. Some scientists, including prominent physicists and neuroscientists, suggest that consciousness might be more fundamental than matter itself. That instead of consciousness emerging from matter, matter might emerge from consciousness. If Wheeler is right, then reality as we know it is in a constant state of flux, only becoming real when we observe it. This means that our conscious observations don't just reveal reality they created, not just now, but backwards in time, all the way to the beginning of the universe. Every time we make a measurement, every time we observe something, we're not just passively recording information, we're participating in the creation of reality itself. This idea becomes even more fascinating when we consider quantum entanglement, what Einstein called spooky action at a distance. When particles become entangled, they remain connected regardless of the distance between them. Change one and you instantly affect the other, even if they're on opposite sides of the universe. This suggests that at some fundamental level, everything in the universe is interconnected in ways we're only beginning to understand. But think about what this means for your own existence. Every observation you make, every conscious moment you experience, might be contributing to the very fabric of reality. Your consciousness might not just be a byproduct of the universe, it might be an essential ingredient in making the universe real. So here we are on this tiny planet in this vast universe that's like an infinite library where every book is written in a language perfectly suited for us to understand. Whether you believe in cosmic coincidence or conscious design, one thing is becoming increasingly clear. We're not just passive observers in this cosmic drama. We're more like co-authors of reality, each of us contributing to the greatest story ever told, the story of existence itself. Thank you for joining me on this mind-bending journey through the nature of reality itself. If you enjoyed this exploration of consciousness, quantum physics, and the fundamental nature of existence, make sure to hit that subscribe button, and don't forget to check out our related video on the multiverse and Schrodinger's cat. I've linked it in the description below. Until next time, keep questioning reality. It might be stranger than you ever imagined.